Good afternoon. We are going to solve an exercise related to the scalar product. The exercise is number 3 on page 162. The exercise says, given two vectors verifying that the magnitude of u is 4, the magnitude of v is 3/2, and the angle they form is 30 degrees. Calculate. You have different questions. So we start with the first one. In the first one, we have to calculate the scalar product of u and v. So we use the definition of this operation. The scalar product of two vectors, u and v, is equal to the magnitude of the first, u, times the magnitude of the second, v, times the cosine of the angle they make. Cosine of the angle that u and v form. So we substitute the data. Because the magnitude of u is 4, we put 4, times the magnitude of v, 3/2, times the cosine of 30 degrees. The cosine of 30 degrees is the same as the sine of 60 degrees, that is the square root of 3 divided by 2. So when we operate here, we simplify 2 and 2 with 4. Finally, we have that the result is 3 times the square root of 3. Second question, scalar product of v and u. We know that the scalar product verifies some properties. The first one of them is the commutative property or law. So the scalar product of vector v and u is equal to the scalar product of the vector u and v. So the solution of the second exercise is the same as the first, 3 the square root of 3. To solve following exercise C and D, we use another property of the scalar product, the associative law by scalars. So we can say that minus 1 times u multiplied by in a scalar way with v is equal to the number that is written before u, minus 1, times the scalar product of u and v. Because we know the solution of the scalar product of u and v, that is 3 the square root of 3, the final result is 3 times the square root of 3. We do something similar in D. We have a product of the scalar 3 by the vector u, and the same with the scalar minus 5 and the vector v. Applying the associative law, we have the product of the numbers 3 times minus 5 times the scalar product of u and v. So at the end, we have minus 15 times the scalar product of u and v. Because this value is 3 the square root of 3, the final result is minus 45 the square root of 3. To finish the exercise, we have D. Here, we have the scalar product of u and itself. We saw one of the applications of the scalar product in class, the second one that says that the scalar product of one vector by itself is equal to the square of its magnitude. This is a consequence of the definition of the scalar product, because the scalar product of a vector by itself is equal to the scalar product of the first vector, that is u, times the scalar product of the second, that is also u, times the cosine that the vector make with itself. Because this angle is 0 degrees, the cosine of 0 degrees we know is 1, so at the end we have the square, this is 1, this is 1, so at the end we have the square of the magnitude of u, because we know u, the magnitude of u, that is 4 squared, at last is 16. And to finish, we have F. In F, we use the two properties. The associative product of scalars by scalars, that is minus 1 time the scalar product of v times v. And finally, because we multiply in a scalar way a vector by itself, we have the magnitude square of this vector. Because we know that the magnitude of v is 3/2, we have at the end minus 3/2 squared, that is minus 9 divided by 4. And we finish. I think that you understand it very, very well. So I see you in the next video. Thank you very much. See you on Tuesday.